So I'm going to go over your lab for this week. And just for attendance, the code today is 532. All right, so your next lab is using wireless on Arduino. So there are, again, different types of wireless connectivity. Your Arduino does not have Bluetooth, but you can get a Bluetooth module for the Arduino, and you would be able to use Bluetooth. Your kits do not have a Bluetooth module. So in terms of, for this class, you will not be working with Bluetooth. Your kit does have an RFID module. So you can work with RFID on the final project if you want to. What we are going to work with on this lab is Wi-Fi. And some Arduinos have it built in, but our Arduino does not. So you're going to work with a ESP chip. It has an 8286 on it. And that is what we're going to work with on this lab. We are going to communicate with TXRX, which is essentially USB. So this is how we're going to connect that ESP8266 to the Arduino board. These are the pins for your ESP chip, and they are oriented like this if you look at the chip like this. Okay. They are not labeled on the chip. So refer back to this diagram or Google, and you'll be able to figure out the pins. All right. So as always, we need to power this chip. So we have 3.3 volts down here, and we have ground up here. So you should connect that to 3.3 volts and the ground to ground. It does not like 5 volts. If you give it 5 volts, probably wouldn't be any problem, but it could kill the chip. The other pins that we are going to use are, we have TX and RX. So that's this pin and this pin. That's for our communication. And one thing that you need to know is the TX from the ESP goes into the RX of your Arduino. The RX of the ESP goes into the TX of the Arduino. So it's not RX to RX and TX to TX. It's RX to TX and TX to RX. And the other thing that you should know is on our Arduino Mega boards, we have 3 different pairs of TXRX. There's TXRX0, TXRX1, TXRX2. The starter code I give you expects you to connect to TXRX1. So I believe it's pins 18 and 19, or 19 and 20, something like that. You do TXRX0 is used by something else by default. So unless you add some more things to the code, you can't use TXRX0. So just use TXRX1 and everything will be good. Okay, and then the other things that you need to connect are the reset pin, enable pin, and those are just connected to 3.3 volts. And the other 2 pins of the ESP are I/O pins. These are for connecting like a sensor or something directly to the ESP. We are not reprogramming the ESP though, so we are not going to use these pins. So if you wanted to connect a sensor, you just connect it directly to Arduino, right? But this ESP chip is reprogrammable, and you could run it all on its own if you wanted to. But we're not going to do that in this lab. Right. So just like the last lab, we need to install a dependency for our library. And this library does not show up on the Arduino managed libraries by default. You have to add this link right here to your additional board manager URLs. This also lets you program the ESP8266 directly if you wanted to. But to get to this page, you go to File, go to Preferences, and then this will show up. And you just need to paste this link here and then hit OK. And then once you have pasted that link, then you can go, just like we did for the LCD lab, go to Sketch, Include Library, Manage Libraries, and we're going to search for Wi-Fi ESP. And this is the one that I installed. Other versions might work, but just so you know, the starter code that I gave you is tested with version 2.2.2. And you're going to install it just like you did for the LCD library. And once this is installed, you can, and you've connected the ESP to your Arduino board, then you can load the starter code. And here's the starter code. So we're using that library that we just installed, right? And here we're creating serial 1, which is used to communicate between the Arduino and the ESP chip. And this is my RX pin 19, TX pin 18. So this is why I was telling you, just use TX-RX1, pin 19 and 18. And you don't have to change the code if you do that. If you use TX-RX2, you have to change the code here. If you use TX-RX0, you have to change the code here, as well as add more code in order to decouple whatever is using it by default. And then here on line 10, this is your network's name. So you cannot use CSUSM Wi-Fi to do this lab. CSUSM Wi-Fi does not let you communicate between devices over the network. So a couple ways that you can do this. If you're going to do it here, you can use your phone as a hotspot. Or you can do it at home on your own Wi-Fi where you can allow network devices to communicate to each other. So that's your network SSID, so the name, and then the password. And then this is the port that we're going to use to communicate with. And it doesn't really matter what port you choose. You can change this to whatever you want. It just needs to be the same between the two Arduinos. And then this is the buffer that we're going to use to hold the incoming messages. This is the buffer we're going to use to hold our outgoing messages. So right now it's empty. So you can fill it in with whatever you want, whatever message you want to send. And then we're just creating this UDP. This is the communication protocol that we're going to use to communicate between the two Arduinos. All right, here is setup. This is to initialize our serial so that we can print out the messages and any status updates as well, like attempting to connect to the SSID, things like that, connection failed. All of these status updates will be printed to serial. And then we're also creating the serial for the communication between the ESP and the Arduino. And this is the baud rate that the ESP likes. Do not change this baud rate. Okay. And then the rest is just initializing Wi-Fi, connecting to the Wi-Fi, and then starting to listen. Don't need to understand this code. Okay. Just know that all of the other things that are not printing, they are required if you are going to use this for, say, your final project. All right, that was our setup. This is our loop. So in loop, there's these two different blocks of code. This first block is used to send a message. So this empty string is the IP address of the other ESP that you want to send the message to. So you can get that from your router network manager if you do this at home, or if you have a hotspot on your phone. The hotspot on my phone, I can see the connected devices. I can see their IP addresses. You just get that directly from there. Or if you're unsure of how to do that, another way that you can do it is you can download a app on your phone that just is an IP scanner, returns the name of devices and their IP address on the network that the phone is connected to. And you're just going to look for what are my ESPs. Okay, so that's the IP address. So it's the address of the other Arduino. And then this is how you send the message. So you're going to write your reply buffer and then finish sending the message. Then after this block of code is a block of code that's seeing, do I have a message that was sent to me? So it gets the packet, and then if the packet size is not 0, then it says, we received the packets, this is the size, it's from, and it's going to print out the IP address of the other Arduino. Okay, so it gets the IP address, and then it prints it, and then it gets the port, and it prints the port. And then it's going to read the message from the packet buffer, and then it's going to print out, this is the contents of the packet buffer. So this is our template for sending, template for receiving. And that is the code portion. So if you want to use this in the future, you can use these templates, okay, to send and receive messages. You'll add some more control code around them to control when a message is sent and when you're trying to read a message. But for this lab, your code is just, I'm always going to send this message and I'm always going to look for a message. And that's what both of them are doing. So there's no actual meaningful communication between the two. It's just, this is the message I'm always sending. This is the message that I'm going to read. Okay. All right. So like I talked about, you need to find the IP address of your ESPs. So you can log into your router, find the ESP, look at its IP address. You can download an IP scanner app, or if you're using a hotspot that supports just, here's the devices connected to your hotspots. These are their IP addresses. And another thing that you can do is you can connect directly to the ESP serial, there's AT commands, and you can tell it to print out its IP address. But this is probably the hardest thing out of all of these options. So you will need to find the IP address though. And you will have 2 Arduinos for this project, okay? Because we're going to communicate through Wi-Fi between the 2 Arduinos. So for this project, you can work in groups of 4. So one group sets up an Arduino, the other group sets up an Arduino. You connect to the same Wi-Fi network, find your IP addresses, and then send the message. And you should see those messages printed on the serial. Okay. And for you guys, it is groups of 4. So just get Adam to find another person. Or if you want to work as a group of 3, just take 2 Arduinos. Okay.
I think me and Sophia have 2 Arduinos total.
Yeah, so then you have Adam and you're a group of 3. I'm just saying maximum 4. Yeah. Okay. So that is your wireless communication plan. So this can be useful when you're deploying a bunch of Arduinos that need to and talk to each other, right? That is the lecture portion of this lab. I will, again, you have the rest of this time to work on your labs and the rest of the week to work on the labs. And at some points, probably next week, I'll talk about the final project. And once we're done with this lab, your final project is the last thing that you have to do. And you'll have the rest of the class time to work on the final project. Okay?